channel. In this video I'm going to show you on Form 4 Physics Chapter 2 Part 7 Pulley System. Now in this video it's actually similar to what you will learn in your textbook or reference called leaf. To start out with, first condition or the assumption you must have about pulley system from 5 SPM would be the pulley has to be frictionless. There's no friction. Okay, no friction, and the tension in the force, the tension in the rope is the same along the rope. Okay, let me give you a condition, an example. Perhaps we learn from example. Okay, this is a pulley, and then you have a rope, go around over it. Okay, and then there is your load or mass M. Okay, this I will assign to 3 kg. Okay, and what happened is, well, maybe a user, you, are pulling it. Okay, what happened is you need to consider it can be split into 2 different frame, left and right. Okay, over the left, what happened? This mass M, they have a tension pulling it upwards so that it won't go down. Over the left hand side, this person or you is giving it a pull, F, force, so that it will balance with the tension applied caused by this pulley. And over the pulley, the direction of the tension force changes. Okay, so that would be the second condition. I mean, it is something you should know. When the tension, the force pass through the pulley, the direction of the tension changes. Okay. Now what happened if you were to pull? Okay, what happened when this mass is not moving? Case 1, when it's stationary, when going down is mg, or you put it the other way, when my T is equals to F, meaning they're balanced off each other. What happened? This object will remain stationary, meaning it's not moving up nor coming down. They are the same. Okay. Or another condition would be they do not accelerate, but that doesn't account for, I mean, stationary. But stationary meaning it's not moving. But not moving, T and F should be the same. Okay. Separate condition. Now you were told that this object accelerates upwards. A is 4 meter per second, 4 meter per second, going upwards. You need to find out what is T. Okay. So how do you do that? First of all, you need to start out with your free body diagram. So assume you are the box or the load. Now this load, you need to ask yourself, in order to sketch free body diagram, you need to label force act onto it. First would be gravity, mg, pointing towards the earth. Then the next force would be the tension. Force act onto it. Yeah, it's always the force act onto it. Please take note, the length of T should be longer than the length for mg, because otherwise this object, and because of that, this object accelerate. This is the effect. Okay, acceleration going upwards. A 4 meter per second. You have your M is 3 kg. So this is the free body diagram you need, so that you'll be able to find out. Well, first I define positive, going up as my positive direction. So because the acceleration going up, so I define acceleration up is positive. So first of all, tension is positive, so tension positive. mg going downwards, opposed to what you define positive. You need to define it, otherwise you doesn't know where to go. Going up t minus mg, because coming down is opposed to what you define positive, so that's why it's minus. What else? This overall object, what happened? This m, what happened? Is accelerated by ma. Okay? Easy. Then all you need to do is solve it, because you have most of the data already. It's given. Bring it over. Negative and positive. So therefore tension would be 3. You may use 10 meter per second in SPM, but not in after SPM you need to use 9.81. But for now you use 10 is okay with that. Okay, and yes, taking care of the direction, you're taking care of the sign, so doesn't worry. Is it correct? Okay, because I define positive going up. So it's a good practice to always define where is your positive direction. So you solve this, eventually you will get 42 Newton. Okay. Okay. So I'm here to give you some notes. This one is stronger because it's force is because it's longer. This one is stronger. This is weak. It's so short. Okay. You need to learn how to really look at it and then find out what is to what. Okay. Now there are many more questions on Pulley system, but the concept or the essence is what I've shown you here. You just need to identify what are the force act onto it, onto the object that is being accelerated up or down. Okay. Then and the arrow tells the direction. Now if you were to go through your reference or textbook, it will give you some example, like over here. Maybe I can want to show you a lift system. You are in the metal box. Okay. Of course, there's a cable. Okay, and you stand onto the scale. Okay, okay. And what happened? The leaf moves up. Okay. Leaf system, what happened? It goes up. Okay. At constant velocity. Okay. Now constant velocity is the keyword, because when velocity is constant, from my previous video, velocity and acceleration is actually the change of velocity over time, rate change of velocity over time. So when the constant velocity, meaning there's no change in velocity, so therefore your acceleration will be equal to 0 with constant velocity. Okay, so if a constant velocity, this object, this leaf moves up, what would the value shows here? Would it be more than or less than? Okay, so how you start off? You start off with, this is a tension onto the cable, pulling you up, and this value is the same as the value act onto you. Okay, and at the same time you're going to have mg going down. Okay, or if you doesn't want to label this T in some book, they would label mg and go up. They call R response. Okay, regardless of how you define it, but at least there are always two forces onto it. So what happened? Goes up. If you put it into free body diagram, a dot, and then mg, okay, and for this case, it actually doesn't know whether it's longer or shorter, because you need to find out what is the reading, what is the R. R is the reading, or T sometimes. If you put a T here, then you don't put an R, because this value and this value should be the same. Okay, and this object is not moving. Okay, not moving. So how to do that equation? At positive upwards. Okay, R positive minus mg. What else? Total is m a. Right, this is general equation from there. Okay, but since a is 0, so therefore m is supposed to be equals to r equals mg. So when the move is not moving, you put a scale onto it. The value of the scale shows here is actually your true value of your weight. Okay. Now what happened? For the same scenario, now when the leaf goes up again, goes up in acceleration. Okay, so how? If you draw it, first sketch a free body diagram. So if says goes up, normally it should be longer. Okay, it goes up, then it should be longer. Force R, then mg should be short. Direction, this is where the direction gravity act onto it, and then goes up, there are acceleration. Goes up with acceleration a. So what happens? So overall effect, yes, this is a. Then in order to get an equation, what we'll do, there will be r. Oh, I positive going up. R subtract mg is equals to ma. So what's the r? R is always the true value that you read from your leaf. When this leaf goes up, your value should increase. The value in your scale, if this is bring over, right, you bring it over. This is positive, okay? So you'll find that the reading on the scale is increased by this value, ma. Okay, your R value, your reading should be greater than the weight. Okay, when this object moving up. The same is true. What happens when this object, this leaf goes down? If now this leaf goes down, I will assume going down should be longer, up should be short, because the overall effect is going down, because I need to at least tell you which direction it's going down, A. Then depends on how you want to define your positive. You may define according to the direction of your acceleration. Your direction of acceleration going down, say for I positive going down, meaning going down is positive. Doesn't really actually matter. Yeah, it just helps you on the sign. So mg going down, and I define positive. So we could do, therefore it will be mg is positive minus r. Why is it minus? Because direction of R is going upwards, where I define positive downwards, so you get a negative sign. What else? There's no other force, but this object was seen to accelerate downwards. That's why it's positive. So what is my value of R? So therefore, the value of my R, you bring it over. My R would be therefore be mg, ma bring it over minus ma. Then you appear to be lighter. I mean, you appear not to be so heavy. Okay? So the reading, R reading should be less than your mg. Put it into a layman term. If you stand into a leaf, this leaf goes down by an acceleration, accelerate downwards, you will feel that you are floating. You have a sensation that you are floating, or you have a sensation that you appear to be lighter. So this is what it means by that. Okay? So when an object goes down, you feel lighter. You feel that you are floating to it. Okay? So two different conditions. This one goes down. Okay? This one goes up. Okay? A is the effect of how this object is being moved up or down. Of course, there are, from a book or reference, you may have questions with maybe two objects over a table and you have friction on it, but the same concept applies. Okay? The same thing applies to if you have two objects with a pulley. So what you do would be you need to pause this video and then go through those questions relates to leaf and pulley system. Learn the essence here would be learning how to sketch a free body diagram, because based on our previous video, part 6, I've exposed to you on what is a free body diagram. Okay? Before you proceed to my next video. Now there are, from your book, also there is something that you should have read, okay? But just in case you have missed it out, something called the free fall. Free falling. Okay? Free falling object. Free fall, okay? What does it mean by free fall? Free fall occurs when the object is under the force of gravity. When it is under the force of gravity, what happened? You have mg, right? Like what I have shown you earlier. And the direction of it is always towards the earth. Under the force of gravity, and another condition will be it does not encounter, meaning there's no other force than gravity, does not encounter other force. When the question says is free falling, meaning there is no other force but gravity itself. Yeah? No other force. Okay? No other force, meaning there's no air friction, air drag, or air friction. I hope you know what's air friction. Or air resistance. Meaning in the free body diagram, that's only mg. When that occurs, it means free fall. The object is undergo free fall. It's only gravity. No other force but gravity. But then of course along the way you read about what's the difference between mass and what's the difference between mass and weight. Maybe W is symbol. This is M. Okay. This symbol shares, across the chapter. In this chapter, weight is W. later on you have what is W. Okay, so what's this? Okay, what's the difference? Okay, first the difference, obvious difference is, what's mass? Mass actually tells amount. Okay, it tells amount of matters. It's amount of matters. How many molecules? How many atoms over the object is amount. It tells amount of matter. It's not metal as in steel. Metal is a matter. It's how many atoms or how many molecules, and therefore it will be constant everywhere because you can't destroy mass. Constant everywhere. This is just a value, how many numbers, therefore it's a scalar quantity. It's just a value, how many. And yes, base quantity is also a base quantity. Mass is a base quantity, which I've covered in my chapter 1 video. And then the unit SI would be in kg. Now unlike for weight, okay, weight is actually caused by the force of gravity. This is caused by cause of gravity on an object. Therefore, it varies with what with the magnitude. Okay, with the magnitude of gravity, gravitational pull, of gravitational acceleration. Your weight here in the moon, as compared your weight at Earth, will be different from the weight at moon, because the moon is 1/6 gravity. You get 1/6 of your weight if you're in the moon. It's a vector quantity because it's always the weight is always towards the Earth, so there's a vector quantity. And you should have some idea what does it mean by derived quantity, because it's meter per second kg. Kg ms minus 2. Unit, special unit called Newton, or is kg m per second. Okay, so that's the difference. That's the difference between these two terms. Okay. What you are about to see next would be called frictional force. It's not really in the syllabus, but I think it's good to include it. Frictional force. If you read through your text, they actually mention it. Okay, there are two types of frictional force. One is called the static frictional force. Another one is called dynamic force, dynamic frictional force. Now, what's the difference? The difference is static is when this keeps the object from sliding through, object from moving. Okay, like you walk on the earth, you don't fall because, or an object hanging. Okay, I think I've gone through it also. Earlier, you have an object, maybe a rubber eraser onto a wooden table. Okay, wooden table. Okay, what happened if you were to lift one side up? This object was seen static here, by a given angle until about this angle. You keep increasing it until it starts to move Okay, the moment it starts to move, then it belongs to this one. Keeps object moves forward. Okay. Okay, this is where the third law of Newton, force and reaction force. How do you calculate them? Is there any calculation? It's actually yes. When this object, well, for this case, is not moving, what happened? Yes, free body diagram, you may sketch onto the diagram. Going down is mg, and the response force here obviously going up r. Over here, not moving, 0 degree, there's no tilting. When theta is 0, what happened? R response is equals to mg. Right? Now, the interesting part about frictional force, there is a general equation very similar to force is ma, but frictional force F may be friction small f. Friction is equivalent to mu normal force R. Okay? Please don't confuse this N with Newton. This is actually called the normal force. Normal because it says it is 90 degrees from the horizontal. That's why it's normal in mathematics. What is S? This is mu. This is coefficient. Different material, they will have different coefficient. How well the object resists to move. Okay? It's a coefficient, it's a constant number. Okay? So if you were to know, if you know what's the mg, the n, normal force, why you call it normal? Because it's here, this is horizontal, this is normal, 90 degree. Okay? So if you know what is the normal force, or you know what is mg, where n equals to mg, so obviously we're able to find what is frictional force. Mg. You doesn't need to know how to find out mu, because if you manage to derive it, mu is equivalent to tangent theta. Okay. This is the angle where the maximum angle where the object starts to move, so that you get a static coefficient. Okay. I think doesn't need to really go down. How do you get y is a tangent? If you are really interested to find out, all you need to do is that object now like an angle. Okay, what happened? I don't mind to tell it here. What happened? This is horizontal, this is vertical with respect to this table in this maximum angle. So the direction here is mg. So the angle here should be the maximum degree theta. So if you were to, based on my previous video, actually I had shown this how to do it in the previous video. So the component force drop perpendicular line. Okay, going down. This one here is mg cos theta, whereas the one going this direction or going this direction similar is actually mg sine theta. Now what happened when this object is raised up to an angle with respect to the earth? This object, before it starts to move, or impeding motion, before it starts to move, going down are supposed to have a force pulling it. This should be a force pulling up outwards, and this is the frictional force. This frictional force equals to mg sine theta, right? That's why it's not moving until a time mg sine theta is greater than Fr, frictional force. Then this object will start to glide down. Okay, when mg sine theta keep increasing because sine theta keep increasing until maximum exceeded Fr frictional force. Therefore, this object or this eraser will start to glide down. Now, how am I going to do that? Here, before it starts to move, impeding motion, Fr is equivalent to mg sine theta. But based on the definition, frictional force is mu n. And n, normal force, is the one here. Going up is the normal force. This object is not flying up or going down. So therefore n is equivalent to where normal force, please do not confuse with Newton. Newton is a unit, normal force is a quantity, is mg cos theta. Applying to the equation for frictional force over here, therefore frictional force is mu n, so therefore mu n is normal force is mg cos theta, here to here, is equivalent to mg sine theta. And therefore mg will be cancelled off. Therefore your mu static just before start to move, sine over cos is tangent. Okay, maybe you want to write out. Maybe you haven't learned sine cos tangent. Okay, so sine divided by cos. You doesn't need to blame yourself because of not knowing its cos tangent, because you haven't learned it. You haven't learned trigonometry at this point. So mu s is actually sine over cos, which is equivalent to tangent theta. Okay, it's pretty simple. So this is how you want to test, and this is how you want to find out what is the coefficient of friction. In the event it does comes out in SPM, look for the coefficient of. How do you look for the coefficient? You doesn't need to do that. You just know it's tangent theta, the angle, before it start to glide down, before it start to move. Okay, so this is a bit of short notes for you. Maybe it wouldn't come up in SPM. Who knows? Maybe you encounter some home exercise at your own time. You found this kind of question. Maybe you can answer those. Okay, that's all from me. I hope you subscribe to my channel. YouTube channel is free, and it keeps you update of my upcoming video. Do press on the thumbs up button. It costs you nothing. It means you like my video, even if you don't literally like it, but just press on the thumbs up button. It makes me feel great. And always, practice makes perfect. Until then, stay tuned to my next video.